Hello everybody, welcome back to All Things Nautical. In this video we'll be having a look at the tidal question on particular tidal data, and then we're also going to see how do we approach a question where we need to find out what the tide will be at a specific time, or for instance at which time we will have a specific tidal height. So the question could give us the following information as indicated in this table on the left here. So it gives us a date, and the date here is on the 15th of June in 2005. The time is approximately 1:30 in the afternoon, 13:30. The speed that the vessel is doing is 18 knots. The draft of the vessel, the maximum draft, is 12 meters. And in the shoal, so this is the area that we actually need to pass. So this could either be a shoal or it could be a bar at the entrance of a port, or whatever the case may be. So it's some submerged item at a depth of 8.1 meters. Now this is a charted depth. So the depth on the chart is 8.1 meters. So the shoal is 8.1 meters deep, and it is also 6 nautical miles from the port where we currently are in the port. So from our berth, it's another 6 miles. And then the ship's clock is set to GMT -3, and that'll be for Argentinian Standard Time. So the first thing we need to do before we can actually start calculating tidal information is to actually see the time that will take in order for us to get to the shoal. So in this case we're doing 18 knots, and we know that the shoal is 6 miles away. So therefore we just do a simple time calculation there, and that indicates to us that we basically need 20 minutes to get to the shoal. So if we're leaving at 13:30, we're leaving the berth at 13:30, that means our ETA at the shoal then will be 13:50, 10 to 2 in the afternoon. So the required depth that we need, so the question might tell us that the underkill clearance at all time, in this case, will be 2 meters. So at all times the underkill clearance needs to be 2 meters. We already know that our maximum draft is 12, so therefore the depth that we require will actually be 14 meters. So when we're clearing that shoal, we need the depth to be 14 meters, and we know that at the moment the charted depth is 8.1. So that basically means that we need an additional correction, and that'll of course be the tide. So we're gonna need the tide to be the following. So we need a depth of 14. Current depth that we have available is 8.1 according to the chart. So that means we need an additional 5.9 meters, which will have to be the tidal height for us to actually clear that shoal with a 14 meter depth that we need. So we need 5.9 meters of tide. So the standard point, so in this case we're just using the one single port, Punta Loyola in Argentina. That's going to be the standard port. So what we need to do now is we actually need to say, okay, we need a height of 5.9 meters. So that we know, we've just calculated that. So we need 5.9 meters. The date we already have is the 15th. So the date is the 15th of June. And what we now need to do is we actually need to find out what is the height at high water. So what's the height and also the time of high water, and we need to find out what is the time of low water and also the height of the tide at low water. And where we're going to find this, for this we need to actually go into Admiralty Total Tide, and we need to find this information for that particular port on that specific date. So this will be given to you as an extract in an exam question. So this is an extract over here of that port for that particular date. So here we can see this is the 15th of June. So there's 4 tidal sets throughout the day. So at 3:27 in the morning is high tide, and the height is 8.7. Then at 10:15 it's low tide, and the height at that time is 3.3. Then at 16:15 it's high tide again, and it's 8.8 meters. And then at 22:32 it's low tide again, and this time it's 3.8 meters. So at the moment for our vessel we're at 1:30 in the afternoon. So that means we're falling in between this the low and the high tide over here. So in between 10:15 and 16:15, which we can see is a 6 hour span. So what we need to do is we need to now go back into this table over here and insert this information. So for this port, the time of high water is 16:15 and the height is 8.8. So the time for high water there will be 16:15 and the height is 8.8 meters. So for low water, which will be now prior to that, so low water over here, the time is at 10:15 in the morning and the height was 3.3. So there's 10:15 and a height of 3.3. Now in this case, this information given here was for the port Punta Loyola, which is a primary port. So in this case, we don't need to apply any further corrections with regards to changes or secondary port or any of that. So this is our primary port. That's all we're going to need. So the last thing that we need to put in here is the actual duration from low water to high water in this case, which is 6 hours exactly. And then the actual range, the tidal range over here, which is going to be 5.5 meters. So from 3.3 to 8.8, that gives us a total tidal range of 5.5 meters in the duration of 6 hours. So what we'll need to do now is, in addition to this, we've got our information from the table. So now we'll need to have a look at our graph, and this graph basically represents the tidal change at a primary port on a specific day. So what we need to do is we're going to look at the center of the graph here. This is basically the alignment with high water. So if you're coming right back down to the center of the graph there, it says high water, and then I've already inserted the time here, which was at 16:15. So it goes 1 hour ahead, 2 hours, 3 hours ahead, etc., and then the same coming back. So in our case that we're busy with now, we're basically working from a time at low water towards a time at high water. So we're dealing with a rising tide. So therefore we're going to be working on the left-hand side of the graph over here. So if high water is at 16:15, we're going to be coming back at 1 hour intervals. So 3:15, 2:15, 1:15, etc. Looking all the way back to 6 hours. So you will see that there's three graphs basically drawn, so three bell-shaped graphs. The first one, the outer one, is for a 7-hour range. So it goes from -7 to +7. Then the middle one is for a 6-hour range from -6 to +6. And then the inner one is from -5 to +5, which is basically going to be a 5-hour tidal range. So in our case, we're using the 6-hour range, so we'll be using this graph that runs along the center here. So we know we're going to be using that graph, and we also know what our times are. So what we're basically going to do is we'll be working with a set time. For instance, we're starting at a set time of, let's say, 3:15 in the afternoon, so 1 hour before high water. Then we'll be working up towards that center graph, the 6-hour graph that we're using, and then from there we'll be coming in a horizontal direction towards our actual tidal height difference. So this tidal height difference that I'm talking about, that basically is going to be a line that we need to connect between the low water height, which is down here, and your height at high water, which will be up there. So in essence, if we're looking at these figures at the bottom here, so we've got 0, 2, 4, 6, 8, and then we've got smaller ones for 0, 1, 2, 3, 4. So it's basically just a scale that we're using with. So it's either the single or the double scale, and at the top it's the same. So it's 0, 1, 2, 4. So we've got a single or a double scale. So it's very important that we use the same one in both cases. So if we're going to use a single scale for low water, we must also use it for high water, and vice versa. So in this case, we know that our high water, the height is actually 8.8. So that means that we must be using the doubled up scale. So what we'll be doing is we'll be connecting 8.8 at the top. So our high water reaches 8.8. So there's 8 meters, 9 meters, 10 meters. So if that's 9 over here, we're going to come back 5.2. So there's 5 sections in between there. So it's 8.2, 8.4, 8.6, 8.8, and then 9. So there's 8.9, 8.8 is over there. So then we can see my line starting at 8.8. So all I'm doing is I'm basically connecting the height at high water, which is over there, to the height at low water. Now, because I use the doubled up scale at the top, I'll also be using the doubled up scale at the bottom. So the height I'm looking for at low water is 3.3. So we've got 2 over here, we've got 4 over there, so that means 3 is over there. So again, we'll be using that 0.2 interval, so that would be 3.2 and that would be 3.4. So that means that 3.3 would basically be in the center between those two there. So 3.3 should sit over there. So there we have 2, 3.2, 3.3, 3.4. So we've basically drawn a line that connects the height at high water to the height at low water. Now this line will basically be our reference point. So that is the range in height. So the total tidal range in height, and then this graph will be representing the tidal range in time. So what we want, in essence, when we were dealing with the question basically asked us, what is the difference, or the time difference that we need in order to get a 2 meter underkeel clearance. Okay, so that underkeel clearance, that's essentially what we want. We said this is what we need throughout the period. We always want an underkeel clearance of at least 2 meters. So what is the earliest time that we can basically leave the port, or reach the shoal rather, the earliest time we can reach the shoal where we will still have a 2 meter underkeel clearance? So how we're going to approach this is what we need to go down to this table over here, and in essence what we wanted we will now put in here for heights, then we'll go back to our graph, and that then will basically give us an actual required time. So what we will need to do is basically now find this time over here. And what we're going to do is we're going to start with our height required. So our height required is with the same height required we calculated right in the beginning. We said we needed 5.9 meters in total in order for us to actually have this 14 meters depth that we desire. So we're going to start with our 14 meters, so that's going to give us 5.9 meters required height. Now we know that at low water the height was 3.3. which means we actually need a total rise from 3.3 to 5.9. We need a total rise of 2.6 meters in the tide before we actually get to what we want. Now the total range of the tide we've calculated up here was between low water and high water. So that goes all the way up to 8.8. So the range there was 5.5. So what we want out of the total range in time, so the total 5.5 meter range, we essentially need 2.6 out of the 5.5. Now that gives us a fraction. So that fraction over here we call factor. So that factor, if we take 2.6 and we divide it by 5.5, that gives us a fraction of 0.47. Now this 0.47 is very important because this 0.47 is what we will now use to basically go back to our graph. So if we're looking at the graph again, we still have this line over here connecting the two heights. So we are going to be running along the center line here, and if you're looking at the graph, it says there factor, so there's our factor, and factor goes from 0.1, 0.2, 0.3, 0.4 all the way up to 1. So we want a factor of 0.47. So if we're going up this line here, there's 0.4, that one over that would be 0.45. So 0.47 will lie about somewhere over here. So what we're going to do is we're going to be connecting that to our line there, because essentially what we want is we want to use our 6-hour graph in order to find time. So we're working in this case from a height back to a time. So if we connect that with the horizontal line there, now that basically runs across the graph at this point here. So now what we'll need to do is we need to go to that point, and we actually need to draw a line from that point now right all the way down to the bottom scale that we had in the beginning. So what we've essentially done is we said this is now our total change this is our total change in height between low water and high water, but we're only using a factor of 0.47. That's all we need is a 0.47 fraction, so 0.47 of the total change in the tidal in the heights of the tidal range. So what we've done is we've basically come down to that factor. We've drawn a line through there, 0.47, and that basically goes through our graph, our 6-hour graph. At this point it intersects the graph over there, and that from that position over here we can simply drop a line right down, and that will then give us a reading in time. So if we're going to look at this in the graph over here, basically this starts at 16:15, which is over here, the center at high water, and it's 1 hour down, 2 hours down, 3 hours down, and now we're getting quite close to where we actually need to be. So this is at 13:15, and that little line there will be 10 minutes apart, because there's actually 6 intervals between this 13:15 and 12:15. So that's about 10 minutes. 10 minutes down from 13:15. So what we can do is we will call this, we can call that as maybe about halfway in between. So we'll call that 13:10. So in between 13:05 and 13:15 will be 13:10. So in this case we can simply interpolate. I suppose if we want to be accurate about it, you probably call that about 13:07, maybe 13:08. So we can go with 13:10 in this case. So that time then that we have over there, that 13:10 is essentially what we'll the earliest time that we will actually be able to cross that shoal with that desired depth that we wanted of 4.9. So that's with that factor being taken into account. So if we're going back down here, we know that the time at high water, was at 16:15. The time interval that we read off the graph there was minus 3 hours and 5 minutes, and that then would give us a required time that we just found on the diagram as well, on the graph, of 13:10. So if we're going back to this initial question, it asks for the earliest time that we will basically have a 2-meter clearance. And that's what we just found on the graph there. So we worked all the way down our graph. We started with a height, we worked back down, and that got us to a time of 13:10. So that is the answer to that question. Now, the next part of the question they asked us, but we know from when we started, in the beginning we said it's going to be 20 minutes for us if we leave at 13:30. If we leave at that time, then basically it's going to be 20 minutes for us to get to the shoal. So 20 minutes added to that means we're actually going to reach the shoal at 13:50. So we know from this, what we just checked, that anything from 13:10 onwards, we should be safe. We should have that minimum 2 meters under keel clearance. But at 13:50, we can most likely tell that it should then be more. So let's just check that to see what will actually be our height. So what will we have under the keel at 13:50? So the time at high water we know is 16:15. Then the time interval there we know is minus 2 hours and 25 minutes. So what does that tell us? That tells us how, instead of starting with the range in height between the two the tides on the graph, we're actually going to start with a change in time. So we're going to go back to our graph, and we're going to be remembering this minus 2 hours and 25 minutes. So if we start at high water again, and we're going back 1 hour, 2 hours, and then we said that these small little intervals were 10 minutes each. So that's 10 minutes, 20 minutes, and then that would be 2:25 in between those two there. So what we're going to do is we're going to take that time frame, we're going to take that time of minus 2:25, then we're going to go up towards our graph, where we intersect the graph. We can just stop that line there, so we'll be going up towards the graph where it intersects the graph. Now at this stage you can already read from the graph, you can see that this factor over here that we're dealing with, if you're looking on that horizontal line, because what we'll need to do is we're going to be running across on that horizontal line basically towards our height range, and from that we'll be measuring our height by going vertically upwards. So this factor over here, which stays the same throughout, so that factor there is 0.65. So if we're going back to our table, we can actually put that in there, 0.65. So that's 0.65. And we know that if that's 0.65, then our total range is 5.5. We knew that from the beginning. So that means that the actual rise we want, so if we're taking this fraction again, remember that is a fraction of the actual rise we need compared to the total range. So that means that the actual rise we need is 3.58. The height at low water was 3.3. So that means if you add these two together, so from 3.3 we're going 3.5 meters up or more. So the actual height that we require is 6.88 by calculation if we take that factor into account. So just to check that, we can go back to the graph, and like I said, we had this line running across here at that 0.65 factor. So it crosses our line, our range line, at about there somewhere. So that means we can now take that reading, go vertically upwards, and we can basically read from there. If we go up to that scale, so we're basically now in this case working from a time to the graph running across and then measuring a height. Whereas in the first example we had a height to start off with, we got a factor, and then with that factor we basically worked all the way down to get to a time. So what we just found here in this, if we're looking at this height that we just measured with running that line through there, so we said that if that's 6 and that's 8, so that's 6.2, 6.4, 6.6, 6.8, and then somewhere between 6.8 and 7. So we can call that perhaps 6.85, 6.9, and that basically just confirms what we've calculated here. So there we know it's 6.88 on that factor, and that basically answers the final part of the question, which asked what is the undercool clearance at the intended ETA. So the undercool clearance, if the height that we have available there, the required height there is 6.88. So what are we going to do? We're going to take that 6.88 and we're basically going to add that to our charted depth, because remember this is our height of tide. So we're going to take that height of tide, which is 6.88. We're going to add that to our actual available depth, charted depth, which is 8.10. So that's going to give us, if we take 8.10 and we add, let's round this up to 6.9, that's going to give us a total of 15 meters. So we have 15 meters of water available at that time, and we also know that our maximum draft is 12, and that's going to stay 12 throughout. So if we have 15 meters of water available and we have a draft of 12 meters, then the exact answer to this question here then would be the undercool clearance, which is available water minus draft, which in this case will be 3 meters.